Every hour, the Earth is hit with more energy from the sun than the entire world consumes in a year. Solar panel systems for homes are increasing in popularity and decreasing in price. Many homeowners are discovering the advantages of solar power, and you may have even seen quite a few systems being installed in your own neighborhood. If you're solar curious and want to learn more, it can all seem a bit overwhelming. You're probably wondering, how much does it cost to install a solar system? And how much money will I really save on my electricity bill? Let's start with the basics. In this video guide, we'll provide you a general overview of solar energy, so you can have a strong foundation of knowledge and make the best possible educated decisions regarding solar power for your home. First things first, what is a solar panel? A solar panel, or photovoltaic panel, is a panel made of solar cells. Solar cells are the essential component by which light is converted into electrical energy, and they're usually made up of crystalline silicon. Each solar panel usually contains from 32 up to 96 solar cells. Depending on the way solar cells are made, solar panels are categorized as polycrystalline, monocrystalline, or thin film. The first two categories, which are the most common types of solar panels, are made of crystalline solar cells. The third category, thin film, is made of amorphous silicon. Apart from the typical framed solar panel, there are also other types of products that can be used in residential applications. Frameless solar panels have been on the market for more than a decade. Also, solar shingles and solar tiles, popularized by the Tesla solar roof, are two types of products that are becoming more popular among residential applications because they combine the technology of solar panels with aesthetic integration into the house. Solar cells produce electricity by converting the tremendous solar energy that the Earth receives every day in the form of sunlight, and more specifically in the form of photons. Most typical commercial solar solutions convert sunlight to electrical energy at an average efficiency of 3 to 17%. If we could break the sunlight into the smallest possible pieces, we would get photons. So photons practically are the smallest possible energy packets of sunlight. First of all, the top layer of solar cells have an anti-reflective coating, which helps them collect as much light as possible. Right below, we have the main layer of a solar cell, which is basically a sandwich of two silicon layers. These two layers are specially treated, so that the upper layer has a surplus of electrons, while the bottom layer has a shortage of electrons. What is needed for the extra electrons to move from the upper to the bottom layer is a little bit of extra energy, and that energy is provided by the photons, when the sunlight hits the solar cells. When the solar panels are exposed to light, electric current is generated. The more sunlight hits the solar panel, the more electricity is produced. That means that during cloudy, rainy, or snowy days when sunlight is reduced, solar panels still produce some electricity, but it's limited compared to the electricity produced during a sunny day. Solar panels definitely do not generate electricity during the night, but you can store excess energy collected during the daytime in a large battery. It's important to place solar panels somewhere where the sunlight can hit them directly and not be obstructed by sources of shade like trees. In order to have a complete system that will produce electricity for your home, you need the following components: solar panels, solar panel mounting structures, an inverter, an electrical panel with the necessary switches and circuit breakers, DC and AC electrical cables, and the power meter. Now let's break down these individual components. As we explained before, the solar panels generate electricity when they are exposed to light. More specifically, they generate DC electrical current. But in order to use the electricity produced by the solar panels, we need to have AC electrical current, alternating current, which is the type of current used by your home and by the power grid. So we need an inverter. An inverter converts the DC electricity generated by the solar panels into the alternating current. The solar panels are connected to the inverter not one by one, but in groups that are called strings. In order for the AC electrical current to be distributed to the grid or to the house, an electrical panel with the necessary switches, circuit breakers, and wiring must be installed, while a power meter is used to measure the electricity produced from the installed photovoltaic system. Many modern systems have handy apps for your phone, so you can see exactly how much energy you're producing. Quite satisfying. Generally, residential solar systems are separated into two main categories: off-grid and on-grid. In the case of an off-grid system, the electricity generated by the solar system will be used to cover 100% of the electrical usage of a home, since the house is not connected to the electrical grid, the power company, at all. This can be accomplished by using large batteries that will store any extra electricity produced during the day. The main disadvantage of an off-grid system is its cost, since the use of batteries increases the cost about 20 to 30% compared to an on-grid system. Many jurisdictions do not allow you to operate your residence off-grid, so you'll have to check. In an on-grid system, the house where the solar panels are installed is connected to the main power grid. Electricity generated by the solar panels can either cover the electrical needs of the house, or when you produce more electricity than needed, it's sent to the power grid. This leads us to net metering. With net metering, your monthly electricity bill is calculated both ways, based on the net of your overall energy consumption and the monthly output from your solar panels. If you're producing more energy than you're using, the utility company will actually pay you. For example, if your solar panels have overproduced 3,000 kilowatt hours on sunny days, and you have consumed 4,000 kilowatt hours from the grid on dark nights, you will get billed only for 1,000 kilowatt hours. In some cases, net metering policies actually pay a higher rate for the electricity that's produced from your solar panel system than what you pay to purchase the electricity from the grid. How much you actually save depends on a number of factors, the most important of which include, of course, how much electricity your home or business uses. The average annual electricity consumption for a U.S. residence was 10,766 kilowatt hours, an average of 897 kilowatt hours per month. And a typical domestic solar installation aims to offset 70 to 90% of your monthly usage. Of course, the exact savings on your electricity bill depends on other factors. If your family has electric cars that need daily charging, your electricity requirements might be much higher. Where you live matters a lot. Sunnier is better. For example, a 5 kilowatt installation consisting of 20 solar panels can produce approximately 8,000 kilowatt hours every year if your house is in a hot and sunny state like California. But the same system will only produce approximately 6,000 kilowatt hours every year if your house is in a less sunny state like Connecticut. That means that a 5 kilowatt system could offset between 60 and 80% of your electricity bill depending on how sunny your region is, based on an average annual electricity consumption of approximately 10,000 kilowatt hours. There's a great online tool where you just plug in your address and it calculates how much electricity you can generate and how much money you can save on your electric bill. I've linked to that in the description below. The available surface on your roof, the unshaded part with the appropriate orientation, determines how many solar panels you can install and consequently your savings. A simple case to have in mind is that you need roughly 350 square feet in order to install 20 solar panels, which would have a total power of 5 kilowatts, an average size solar system in the US. That tool I just mentioned actually allows you to select your roof on Google Maps and it factors it into the calculations. The inclination and orientation of your roof are also important. To produce maximum electricity, solar panels should face south, and your roof should have an inclination in which the sunlight hits vertically on average during the whole year. The more you go up north, the steeper the incline of your roof should ideally be. In 2019, the average cost of a residential solar panel is $299 per watt. So with an average solar panel system size of 5 kilowatts, you're looking at an average cost of $14,950 before any tax credits or incentives. Equipment makes up the majority of the cost, but permits and labor are also factored in. You can deduct 30% for the current federal solar tax credit, and there are also many other localized incentives offered by your state or your utility company. These prices of course vary depending on the brand of solar panels, the size of your installation, your installer, and also on your state, but this is just to give you a rough idea of what to expect. The best way to get a good price on solar is to compare quotes from many different installers, and there are some great services for that which have also been linked below. Based on the parameters we've already mentioned like cost, electrical consumption of your house or business, how sunny your region is, a solar energy system provider can help you determine which would be the ideal system for you in order to save as much as possible on your electrical bills. Don't forget that there are many choices regarding brands of solar panels and solar inverters, and a good installer will help you select the optimal system for your budget. The most important parameter that determines whether or not a roof is appropriate for a solar panel installation are its inclination and its orientation. Your solar energy provider can calculate exactly how much sunlight your roof will receive during the whole year. Although solar panels have a weight of only about 2 to 4 pounds per square foot, structural safety is definitely another important factor. For new houses, the design of the whole mounting structure with the solar panels must include a static evaluation of the roof. For existing homes, the service of a professional structural engineer is required in order to carry out an inspection of the roof structure and do a calculation of the structural loading capacity. As there are practically no moving parts in a solar installation, minimal maintenance is required. However, routine maintenance is needed in order to ensure the system is performing properly. Solar panels require routine inspection for signs of damage, buildup of dirt, or shade encroachment. Although solar panels are usually designed and installed in order to be cleaned by rainfall, they should be cleaned manually if there's a buildup of dust or any other obscuring material. Periodically, system mounting structures must be checked for corrosion in order to ensure the photovoltaic system is safely secured. Also, any solar system connected to the electrical grid of a house is an electrical installation, so a licensed electrical engineer should be appointed periodically to ensure electrical safety. To sum it up, here are some pros and cons of solar systems. A true renewable energy source. Reduce your electricity bill and provides insurance against rising power prices. Low maintenance cost. Financial incentives from the government. They operate quietly with no moving parts and emit zero pollution. They have a long service life and reliability in operation. Initial costs, but marginal cost drops to zero once the price of installation is paid off. Weather dependent, so it is an intermittent energy source and cannot be relied on in critical applications. Energy storage systems to smooth demand and load like the Tesla Powerwall are expensive. Are you ready to go solar? Check out the link in our description and input your address to quickly estimate the solar potential of your home. If you have any questions about solar, feel free to ask us in the comments below and we'll do our best to get to as many as we can. This concludes our video featuring some basics about solar panel systems for homes. If you found this video helpful or interesting, please subscribe to our channel. Thanks for watching and have a great day.